Welcome you all to KPKS Physics Academy. Students, these and upcoming videos are especially dedicated to those appearing Cbse or ISC board exam term 1 in coming November or December 2021. In this video, we are going to discuss the multiple choice questions are related to the Coulomb's law according to the sample paper which was released by Cbse. Okay, let us start the class. Coulomb's law. Problem number 1. Two electrons are separated by a distance of 1 Armstrong unit. What is the Coulomb force between them? So the options are given. Now let us solve this problem. Solution. So we know that the Coulomb's law or Coulomb law of force F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by. Okay, now you know that 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9 Q1 and Q2. So there is a two charges is given here. All of you know this, that is electrons. Electrons is given. There is 2 electrons are given. So we know that the charge of an electron 1.6 10 to the power of minus 19. Q2 is also 1.6 10 to the power of minus 19. 1 Armstrong unit is given. So R value is equal to 1 Armstrong is given. So R is equal to 1 Armstrong unit is converted into the meter. So 10 to the power of minus 10 meter upon 1 in 10 to the power of minus 10 meter. So now you simplify this. So 9 into 10 to the power 1.6 into 1.6, this is 2.56. So power now 10 to the power of 9, 10 to the power of minus 19 minus 38. 10 to the power of minus 10 is goes to the numerator. So you take us, there is a plus 10. So now you multiply this. 9 6 are, that is 54, 5, 45. So 0. So the answer 23.04 to 10 to the power of denominator is R squared. So that is a whole term. That is a what about that squared? So for minus 20, that is a plus 20. Minus 20, so plus 20. Problem number 2. Two spheres carrying a charges plus 6 microcoulomb and plus 9 microcoulomb separated by a distance d experiences a force of repulsion capital F when a charge of minus 3 microcoulomb is given to both the sphere and kept at the same distance as before, the new force of repulsion is. So the option is given. So now we are solve this. What are the data are given? Two spheres. Now you draw roughly two sphere carrying a charges. First one is plus 6 microcoulomb. Another one is plus 9 microcoulomb. Plus 6 microcoulomb plus 9 microcoulomb separated by a distance d. So the distance between the two spheres you consider as small d. Experiences a force of repulsion, let me consider as capital F. So that is a capital F. So this one is a case number 1. Case number 1. Now what about that is a case number 2. When a charge of minus 3 microcoulomb is given to the both the sphere. Now you add minus 3 microcoulomb both the sphere. So let us see. According to the addition of charges, so plus 6 microcoulomb which is added with minus 3 microcoulomb. Minus 3 microcoulomb is given. Minus 3 microcoulomb is given. So another sphere. So let us consider first sphere named as A, second one is B. So plus 9 microcoulomb is added with minus 3 microcoulomb. So according to the addition of charges, the law of addition of charges, so 6 minus 3, so we get 3 microcoulomb, 9 minus 3, 6 microcoulomb. So the distance between the two spheres as usual, that is D. There is no change in the distance between the two spheres, but the charge is only different. So now we are going to calculate what about that is new force of repulsion. New force of repulsion. So F dash we are going to calculate. So this one is case number 1. We consider case number 1. Second one is, this one is case number 2. So now you write the equation for case number 1. Case number 1, what about that? F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R squared. So this equation is a general formula for Coulomb's law. So now in the case of first, the force is capital F. Next one is 1 by 4 pi epsilon naught value. 1 by 4 pi epsilon naught Q1 Q2, that is A and B. So now you substitute that. Directly you substitute that. So first case is F. So F is replaced by F. 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9. Q1 value, in the case of first one is 6 microcoulomb. So 6 microcoulomb, 6 into 10 to the power of minus 6. Q2 value 6 microcoulomb, 6 into 10 to the power of minus 6 whole divided by R value. So the distance between the two sphere is small d. So R is replaced by d, that is d squared. So put the equation number 1. Similarly, we write, that is case number 2. The new force of repulsion you consider F dash is equal to 1 by 4 pi epsilon naught value. For second case, case number 2, F dash, the new force of repulsion, F is replaced by F dash. 1 by 4 pi epsilon naught value 9 into 10 to the power of 9. Now Q1 value, first sphere, that is what about 3 microcoulomb, 3 into 10 to the power of minus 6, 6 into 10 to the power of minus 6, so whole divided by, there is no change in distance, so the d is d squared. So put the equation number 2. Now you find out F dash. So equation 2 divided by 1. So F dash value, F dash divided by left hand side, F dash divided by F, 9 into 10 to the power of 9, 3 into 10 to the power of minus 6, 6 into 10 to the power of minus 6 divided by d squared. F dash value, capital F value, d squared divided by divided by 9 into 10 to the power of 9, 6 into 10 to the power of minus 6, 6 into 10 to the power of minus 6. Okay. Sorry. Plus 9 microcoulomb is given. So equation number 1 is 6 is modified by 9. 9. Now you have simplified this. So 9, 10 to the power of 9, d squared is cancelled. So next one is 6 into 10 to the power of minus 6 is cancelled. 10 to the power of minus 6 is cancelled. 3, that is a 3. So right hand side you get that is 1 by 3. So F dash divided by F. You want that is new force of repulsion, that is F divided by 3. So the option D is correct option. Okay. Next problem. Problem number 3. Two charges of equal magnitudes and at a distance R exert a force capital F on each other if the charges are halved and the distance between them is doubled. Then the new force acting on each charge is. So this is the question. The options, 4 option is given. So now try to solve this. All of you listened it. Two charges you consider that is two charges. Two charges. So the dotted is two charges of equal magnitude. Equal magnitude, let me consider as Q and Q. That is equal magnitude and at a distance R. The distance between the two charges is R. Exert a force capital F on each other. So this one is case number 1. You put that is case number 1. Now if the charges are halved, so if the charges are halved and the distance between them is doubled, so the same charges, so previous charges is Q, now the charges is halved, Q by 2, second charge is also Q by 2, the distance between them is doubled. So previous case the distance between the two charges are, now in this case that distance is doubled. So R is replaced by 2R. What about that is new force of repulsion, that is F dash is equal to question mark. So this one is what about that second case. So now you write the force of repulsion is in the case of 1. So F is equal to case number 1, F is equal to, what is the formula? 1 by 4 pi epsilon naught. First charge is Q, second charge is also Q. The distance between the two charges is R. So there is R squared. So we can write 1 by 4 pi epsilon naught Q squared divided by R squared. So put the equation number 1. Case number 2. The new force of repulsion you consider as F dash. So 1 by 4 pi epsilon naught, the charge is doubled. So Q is replaced by Q by 2. Another one is Q by 2 divided by distance between the two charges is 2R. So R is replaced by 2R square. So now you simplify this. So 1 by 4 pi epsilon naught Q square divided by 4R square. So therefore 1 by 4 pi epsilon naught Q square divided by 16R square. So 1 by 16 Q square divided by 4 pi epsilon naught R square. So from equation number 2. So from equation number 1, q squared divided by 4 pi epsilon naught r squared is equal to capital F. So therefore 1 by 16, this one is replaced by capital F because of equation number 1. So the new force of repulsion is equal to F divided by 16. So this is the answer for this problem. So the option is D. F by 16 is the correct option. Next problem number 4. Two charged spheres separated at a distance D exert a force F on each other. If they are immersed in a liquid of dielectric constant 2, then the force, if all the conditions are the same. So what about that is a force? So two charged spheres. So you consider as two charged sphere named as Q1, Q2 are separated at a distance D. The distance between the two charges you consider as D. Exert a force F on each other. So the force is capital F. If they are immersed in a liquid. Now both the charges. So this one is case number 1. In this case, medium is air. That means vacuum. So this one is case number 1. So medium, air or vacuum. You consider that is a vacuum. Case number 2. They are immersed in a liquid. So this system is immersed in a liquid. So the same system Q1, Q2 separated by a distance D. This system is immersed in a liquid. So this one is a case number 2. What about that is a force? That force let me consider as a F dash. So now we are going to calculate the new force F dash. So as usual, first you write case number 1, F is equal to, according to the Coulomb's law, 1 by 4 pi epsilon naught Q1 Q2 divided by the distance between these, there is a D square. So put the equation number 1. Now all of you listen to it. Epsilon naught here, that is permittivity for air or vacuum. Case number 2. So in this case, the charges are placed in the air or vacuum. Second case, that is new force F dash is equal to 1 divided by both the charges are immersed in a liquid. That means liquid means one of the medium. Epsilon naught is replaced by epsilon. Next one is Q1 Q2 divided by the distance between the two charges is D square. This one is first equation is applicable for the charges are placed in air or vacuum. Second equation is applicable for those charges is placed in the medium, either kerosene or any other liquid, water. So epsilon naught is replaced by epsilon. So now you want that is epsilon F dash. So equation number 2 divided by number 1. So left hand side F dash divided by F is equal to 1 by 4 pi epsilon whole divided by 1 divided by 4 pi epsilon naught. So Q1 Q2 divided by d square divided by Q1 Q2 divided by d square. So now you strike out this 1 by 4 pi, 1 by 4 pi is cancelled. So remaining you get 1 by epsilon divided by 1 divided by epsilon naught. So we can write 1 by epsilon naught divided by 1. So epsilon naught divided by epsilon. So left hand side f dash divided by f is equal to epsilon naught divided by epsilon. Okay. So we get f dash divided by f is equal to, we know that equation number 3. So we know that epsilon r is equal to epsilon divided by epsilon naught. This is the relative permittivity of the medium. Epsilon r means what about that? Relative permittivity of the medium. So it is also represented by K. K is called as what about? That is a dielectric constant. Relative permittivity of the medium. Another name is called as dielectric constant. So put the equation number 4. So but take the reciprocal. Epsilon by epsilon naught is K. But epsilon naught by epsilon, using the equation 3rd and 4th, we can get f dash divided by f is equal to 1 by k. K value is given. K value, dielectric constant value is given in the problem. K is equal to 2. Now you substitute f dash divided by f is equal to 1 by 2. So f dash is equal to f by 2. So this is the answer for this problem. So the second option is correct. Next problem. 2 point charges are placed at a certain distance r in air. Exert a force on F on each other, then the distance r dash at which these charges will exert the same force in a medium of dielectric constant K is given by. So the 4 option is given. So what is the distance? The same force. So the question is the distance r dash at which these charges will exert the same force. So we are going to calculate what about that is the distance r dash. So this is a task, our task. Now so 2 point charges placed at a distance, certain distance. So first one is you write the equation F is equal to 1 by 4 pi epsilon naught. Those charges you consider as Q1 and Q2 divided by R square, which is placed in air. This one is air. So equation number 1. Case number 2, that is F dash. Let me consider as F dash. Now both the charges are placed in the medium. The problem is there is a medium of dielectric constant is K. So q1 q2 divided by r square. So second case is the charge is placed in medium, equation number 2. So now what is the distance between this? In the problem, r is replaced by r dash is given. R dash is given. Now equation number 2 divided by number 1, which implies that f dash divided by f is equal to 1 divided by 4 pi epsilon q1 q2 divided by r dash squared whole divided by 1 divided by 4 pi epsilon naught q1 q2 divided by r squared. So 1 by 4 pi is cancelled. So q1 and q2 is cancelled. Remaining term 1 divided by epsilon r dash square divided by 1 divided by epsilon naught r square. Okay. Now you find out there is a r dash. So the force is the same. In the problem, what about that? In the problem, there is a same force. Once you change the distance r dash, the force, but the force is same. There is no change in the force. So f dash is replaced by f divided by f is equal to 1 by epsilon r dash squared epsilon naught r squared divided by 1. So epsilon naught divided by epsilon r squared divided by r dash square. So you know that epsilon r or k value, k is equal to what about that? Epsilon divided by epsilon naught. So but this value is replaced by epsilon naught by epsilon naught. That means 1 by k r square divided by r dash square f divided by f is strike out this, you get the value is 1. So now r dash squared is equal to r squared divided by k. So you take the root r divided by root k. So this is the answer for this problem. So which one is correct? So that is what about the fourth option is correct. So this is the answer. Fourth option is correct. Thank you.